This is AJ sir. Let's study 9th standard ICSE math exercise 6D. Now in question number 2 they have given two equations. What is different in such sums is that the variables x and y are in the denominator. Now one method is to assume 1 upon x as a and 1 upon y as b, so you'll get two new equations. For example, this will become 3a plus 2b is equal to 10. Then we solve them, get the values of a and b, resubstitute, and then get the values of x and y as well. But this sum is easy enough for us to do it directly without assuming them as a and b. So I have two equations. Let's call them equation 1 and 2. I would like to equate the coefficients. Let's equate the coefficients of x, or rather of 1 upon x. So it's 9 and 3, so let's make this as 9 as well. So multiply this whole equation by 3. So I got this new equation, and I'm copying this equation again from 2. Let's subtract them because the signs are same. So this is eliminated. 6 minus minus becomes plus, so that becomes 13 upon y. Denominator is same, so we can simply add the numerators and the denominator will be the same. And here subtraction will give us 19.5. Now I want y alone, so y goes up, 19.5 goes down. Remove the decimal, solve ahead, and get the answer of y. This y can now be substituted in equation 1, and on substitution the denominator goes to numerator, then 2 and 2 cut, 3 goes here and becomes minus 3, this is 7, then 7 goes down here, x comes up, so x is equal to 3 upon 7. Now in the fourth sum again two equations are given. We can solve them simultaneously and get the values of x and y. After that there is some additional task. We'll have to substitute the values of x and y in this equation to get the value of a. Do not take out the LCM because we've got a variable in the denominator. So we'll use the elimination method. Let's eliminate y because it's in the denominator. I prefer to eliminate it first. But for that I will have to equate these coefficients 6 and 4. The LCM is 12. So let's multiply the first equation by 2 and the second equation by 3 so that now the coefficients are same and the signs are opposite, so just add the two equations, y gets eliminated. So the only variable left is x. Solve it, get the value of x. Next, substitute this value in either of the equations, and after substitution solve algebraically to get the value of y. And then in the given equation substitute the values of y as 2 and x as 3, solve and get the value of a. Now mark sum 6.2 as IMP. The denominators have the variables, so we can assume 3x plus 4y as a and 3x minus 2y as b, so that it will be transformed into two new equations, 34 upon a, 8.5 upon a, 15 upon b, 25 upon b. This will make it easy for us to solve this. It will become manageable. We could have taken 1 upon 3x plus 4y also as a, but this would be more manageable. You'll see that shortly. Now this is like the previous sums. We'll have to eliminate one of the variables, but first of all a should be written in front, so I did that, and b is written second. Let me equate the coefficients of 1 upon a. 8.5 into 2 is 17, so into 4 is 34. So let me multiply this whole equation by 4 so that I get minus 34 here, which equates with the 34 of this equation. So now I got two equations which can be solved simultaneously. Let's just add them so that A gets eliminated and B can be added, and solve and get the value of B. Now take any one equation. I've taken equation number 3 here, this one here, and substitute the value of B as 5, so that the only unknown variable is A, and get the value of A as well. But the sum isn't over here. Resubstitution is left. We had assumed 3x plus 4y as A, so A is 17, and we had assumed 3x minus 2y as B's, which is 5. So I got two new equations in x and y, and that is why I had assumed them as A and B respectively, because now it is easy to solve them simultaneously to get the values of x and y. I subtract these two equations. The coefficients are already same, so it just gets cancelled. This has to be added, this has to be subtracted. I get the value of y and then of x after substituting the value of y in either of these two equations. Now even 7.2 is IMP. What is unique about this sum is the xy. So we'll have to get rid of this xy. We simply divide the whole equation by xy. When we do that, we notice that x and x gets cut and y gets cut, and we are left with this equation, and that's something we have handled before. Even the second equation is transformed by dividing by xy, and this is the second equation. So now it's pretty straightforward. Equation 1, equation 2. Let's eliminate x because the signs are opposite, so that'll be easy. Multiply this equation by 3 so that I get 3 upon x with the minus 3 upon x. Adding both the equations, x gets eliminated, y is left behind. I can solve it and get the value of y, and again copy the equation number 1. In that, substitute the value of y to get the value of x. Now the 8th sum looks a bit strange because there are no numbers involved, but the logic will be same. The two equations are given. We would like to eliminate any one variable, either the x or the y. Assume that a and b are just numbers. So I would like the coefficients of y to be same. So for that, I should multiply this equation with a squared, so that this will become a square b, just like this. So let's start with that step. I've copied equation 1 and 2, and equation 1 I've multiplied by a square. Now if I multiply a square here, it becomes a cube upon x. If I multiply a square here, it becomes a square b upon y. And if I multiply a square here, that doesn't make a difference, it is still 0. So I got two new equations. In fact, this one is the new one. Since the signs are opposite, I simply add the two equations so that this variable, the y variable, at least gets eliminated. But what about the first terms? Well, the denominators are same, so let's just add the numerators. ab square plus a cube, I'll just write it down as it is, upon x. And a square plus b square plus 0 is a square plus b squared. So I have only one unknown variable, x. Let's find it. I see that here I can remove a common, so let's do that. And the brackets left is the same as this one. So a square plus b square and a square plus b square can get cancelled. So x can be transposed here. So we get x is equal to a. Now substitute this back in equation 1. Instead of x, let me write here a. So x, I wrote a, so a and a cut, that's 1, and minus b upon y shifted to the other side becomes positive b upon y. No, y won't go up and b won't go down because we are transposing a subtraction as an addition. And then cross multiply to get the value of b as y. So x is a and b is y. Now question 10 is IMP. There are two equations. We'll have to equate the coefficients for both of them. So we'll eliminate x out here. But here we have 3 upon 2x and here we have 3 upon 4x. What if we multiply this by half? Then perhaps both the terms will become equal. So let's do that. So here we have equation number 1. To this equation, we are going to multiply each term by half. That is the whole equation by half. If I multiply this by half, the numerator remains the same, 3, but the denominator becomes 2x into 2, which is 4x. Of course, I'll have to multiply this as well by half. So 2 and 2 cut, it's 1 upon 3y. And this by half, it becomes minus 1 upon 6. So that's a new equation.